Hi everyone, this is Frederick Pellet with Context22 Technology to present you the new functionality developed by Context22 to help companies manage their Guardium environment. This functionality is based on the well-known report in Guardium called Buffer Usage Monitor, generated on an hourly basis for each collector. And this is a standard setup in Guardium. So let's first have an overview of the system. So on the left, you've got the set of collectors you want to see performance data of, and you, as mentioned, you set up the interface to ship the buffer usage monitor on an hourly basis to a box and in a incoming folder. This box should be a Linux box equipped with Elasticsearch and Kibana, and in addition to the buffer usage monitor data, we use metadata describing features of the collectors. Then we take those two set of data and we merge them using a Context22 Python script to make enriched data we upload in the ElasticSearch noSql database. Once there, it can be taken under Kibana, which is a great graphic interface for analytics, and it can be seen from any workstation. So first, let's look at those CSV files of the buffer usage monitor we receive, and basically this is something like that. Right, so each of those files has been generated by the Guardium appliance and shipped to this box. Right, so it's a standard setup in Guardium. You just activate it. So now let's see the metadata of the collector. So those metadata are, as explained here, must be on the box, but actually we store them in Elasticsearch. So let's have a look at those data. For those who don't know Kibana interface, it's an opportunity to look at it. So here, this is a metadata for collector 1. Right, this is the name of the collector, and this is our experience that it's nice to know a few things about this collector, which is not provided within the buffer usage monitor report. So in particular, we think that it's important to know to what central manager this collector is attached. It's good to be to structure the collectors in a way that they don't receive too many different types of database. It makes management of them easier. So here we declare that this collector mostly receive MongoDB data. We also declare this collector as a primary as opposed to failover. We specify the environment this collector belongs to, and also the version, as it may end up having a different version of Guardium in your environment, just because it's not necessarily easy and simple to upgrade. So you know exactly where you are with those metadata. So now let's look at the open source Python program So now this piece here, and actually I'm not gonna get into the detail of it, but it's open source, right? And you can access it in this repository, and I'm gonna put the link into the description of the video. So now let's look at, once the data are merged, what do they look like from a Elasticsearch standpoint. So here we've got different collectors. Then I'm going to show you this one. So here you can see that this is for September 15th at 3 p.m. right? So it's normally it's 2 to 3. It's for and you can see that you can recognize the different value of in the buffer usage monitor, but here you can see that we have added those metadata, and this is what you will be able to see in Kibana. Let's now look at the Enriched Buffer Usage Monitor data under Kibana, which is going to provide a very versatile and graphical way of displaying those data. So let's start with this dashboard, and here you can see we have the metadata here, and the collector are basically grouped along those different metadata. Here we've got a wheel with all the collectors, and we're going to look at two crucial indicators to watch. One is disk usage for MySQL, and the other one is sniffer restart. So let's look at the disk usage for MySQL, and here you've got for all collectors the state of the disk and per database type, and you can clearly see that two stick out, right? This one and this one are probably collectors you need to take care of. And then you want to know a little bit where you may want to redirect some of the agents reporting to those two collectors to new collectors. So to do that, we're gonna try to narrow and the set of collectors we are interested in. So we know it's my MS SQL, and we select MS SQL. It's all collectors are production, and if I want to redirect traffic from the fullest and busiest collector to less active collector, I don't want to risk to move them to a failover collector. Then I select here the primary, and here we've got the set of collectors for MS SQL as primary in production, and you still have those two stick out. And another way of presenting this histogram is to go from ranking from the fullest collector to the less used collector, and you can see now that those are the good candidates for having some of the traffic going to those two or even three collectors to other collectors. So this gives you quickly an idea of where you can redirect. So the second indicator to watch is crucial one is the sniffer restart. You know that if the sniffer for any reason cannot do the work, he gets killed by the watchdog process called nanny, and you may lose some data in memory and so forth. And it's really something you don't want to have. And here my test data don't show a case of restarting sniffer, but if you've got more than one here, it's a sniffer restart, and you know if it happens on production or non-production. All right. Okay, so now let's look at another approach, this time in terms of time series, which is evolution over time. Okay, so this is a one per collector, because first you can see again the very same metadata, allowing for grouping the collector, right? And here those are the sex indicator I think are very important. So it's a little bit squeezed, and it's because of this guy, so we're gonna get rid of it first. And let's go along through those different indicators. Let's do that logically. So this one is the amount of data you receive, and this is as you can see, it's globally over across your environment. It's not just for one collector, it's across the environment, right? So this is how much data you process across the environment. Once again, here it's an analyzer queue. So the analyzer queue is used by the sniffer or analyzer when there is too much traffic, and put that in a queue and process later on. So when there are spikes like here of the queue length, it means that at least some of your collectors may be under stress. Okay, and here the two this one first, CPU load, it's how much your CPU is stressed, and in this case you can see it's not that much. Then MySQL here as well, but we have it shown in the previous dashboard. Then just let's talk about this guy. Okay, so you have to know that a sniffer, because this is about the sniffer, and the memory taken by the sniffer must be a third, maximum third of the total memory. So if you got a 32 gig collector, if you go beyond 10, 11, here it's almost maximum is at almost 11 gigabytes. And if the sniffer needs 12, it's going to be killed by the watchdog called nanny. So this is a good indicator to have as well, because when you get close to those 10 gig, or you may risk a restart of your sniffer. So here let's select one collector and get rid of this one. But here we can see that let's have a look at this. Let's get rid of those ones. Okay, and you can see that the amount of data received and the amount of data processed are quite correlated, which is not very surprising. So let's bring in the queue length, and you can see that there was a massive spike here, but probably it did it, since we don't see any stress on the CPU, except that if we really want to see this, it's here, right? It's okay, and it's 8% of the CPU, which is pretty low and didn't move. You can also do that per group of collectors. And for example, let's see at the collectors receiving MongoDB traffic, and here those are the collector. We are interested in production and not in failover, because failover must not be used. And so those are the three ones. Okay, so we can see the CPU load, right, which is pretty low. So let's get rid of it. Let's get this one, and this one, you see, for those three the maximum is 8. So it's okay. So this one is even 7. So and we've got another dashboard which we're gonna see those stuff per collector in a more specific way. So let's bring back those ones. Let's get rid of this one. And here we've got an idea of globally the system environment behave globally for DB MongoDB traffic monitoring. But overall, it's better to use this kind of dashboard is more for looking at one collector in particular, right? So this is, for example, here, right? So if I remove this one, if I remove this one, what do you have? Okay, so you see, so this is a queue length. It's not terrible, and here this is a desk. Oh, you see it's pretty low, 5%, and average of CPU it's 3. It's very low as well. This is really a good candidate for receiving additional traffic and redirecting some STAP to another one. Okay, so let's look at the third and last dashboard, which is, in this case, instead of having on the same graph all the indicator and variables, we've got actually one graph per variable, right? So here you retrieve the metadata and that way to group, right? Here, logically, first we look at how much you receive, and this is per collector this time. So you can make a comparison between different collectors. Analyzer rate, how much you process, and same thing. You've got those ones. And the queue length. So the queue length, this is where you've got spike. When you've got spike on it, it means that there is a stress on the collector, and you probably want to do something. So let's the one with the stress is 106. So 106 is here. So it's a MS SQL. It's in prod, and it's a primary, right? Then here you can see that the amount of data received is really hectic and variable. Then the analyzer rate has large variation, and here we've got the spike for the queue length. The memory, you see, it's over 10, and it's really close to the upper limit. And the CPU is not that much used, right? So since this is MS SQL and prod and primary, we can do MS SQL, prod and primary, and here we've got all of them. But you can see that 106 is here, but it's not really the main one, except for the queue length, right? So it's it means that probably this one may have something a bit specific, and
very hectic traffic generated or collected by the agent, and maybe here it would be good to split the traffic between different collectors rather than just having one. So this takes us to maybe last one thing also is interesting. It's, for example, let's look at Mongo, and you look at the collector receiving Mongo traffic, and you can see there are some who are not very interested in non-prods and who are not interested really in failover. So you've got actually 3 collectors, and you can see for each indicator of performance those 3, and you can see here there are some size difference, right? So probably looking at this one would be good to get an idea of what, especially because it's confirmed by here, right? Look at that. It's and the spike, the main one, is on this one, right? So 120 is not so it's pretty low, right? So I have 7-8 gig. It's not much, right? You are still quite far from the upper limit, and here, you know, it's not that much, right? 14 out of 100. It's really not much. So this to conclude this part. Okay, so let's wrap up, and before we really end this presentation, let's summarize what we offer. Then, really what Context22 does offer is this Python script and cron shell, cron tab to run it. So we can help the customer or the companies figuring out what metadata may be useful. And the companies have to set up their Guardium environment properly, set up a ELK environment as well. So this is basically what we provide. And thank you for your attention. If you need additional, you've got additional requests or need additional information, please don't hesitate to contact us at info@context22.com. Thank you, and have a good day.